Miles, thank you so much for joining us today. You are currently in the UK, correct?
Yes.
And you're working with Booking.com as a software engineer at the moment,
Yeah.
right?
I recently joined.
I hear you are sort of like a backend wizard and quite well versed in C++, Rust, Java, and Python. So throughout your career, what factors have influenced your decision to work with particular companies or projects or frameworks? Basically, what led you to the place that you occupy right now professionally for yourself?
To begin with, maybe a piece of my background.
Sure.
I started. I worked for a few years at a couple of startups, and then afterwards I joined Microsoft for a few years, like 2 years. There I was also like a software engineer, and then I moved to Meta for another 2 years, again there as an SRE production engineer, and then I just recently joined Booking as a software engineer. So I've jumped like a couple of roles, but I think at the end of the day, engineering is very agnostic of like the tech stack. So if you're an engineer, you end up just picking up languages quickly, technologies quickly, and like that's definitely the definition of an engineer. You're able to pick up like a framework, a language over a few weeks, and then be productive in it at work or like pet projects or something like that. So I do think like having that agnostic mindset when you're like picking a path in either in backend, in front end is very important because the landscape changes so fast.
And what led to you focusing on the back end as well? I understand that picking a stack is kind of something that happens sort of like almost on its own. You find some parts of the job calling to you more or less. But for you, what was your defining experience or preferences that led you down the back end path?
To begin with, I when I started, I did like also try a couple of other stacks. So I did try mobile development for a while, and then I shifted to backend again. The main reason is like I think backend is usually not the technology C, but it's the most important one. It's the one that deals with like making sure the service is scalable, the service is running, the service is like reliable, and that's like the most important part. It has the most challenging part of a problem stack. Of course, like there are like interesting challenges throughout the stack from the back end to the front end. But I think like I am really just interested in like scalability and distributed systems, and like backend is where you kind of get to solve those problems. So that was the main motivation to like try to focus on backend, because the problems there can be massive.
Okay, you mentioned scalability quite a lot. I understand that it's sort of like this part when you're growing a system, basically multiplying it over and over again. This is where the gremlins usually come forward. What are your key considerations or challenges or points of attention when implementing a highly scalable and fault-tolerant systems?
I mean, distributed systems are like heavily researched topic. I think one of my earliest inspiration, I think, would be like the writings from Leslie Lamport from the 90s. They were like really impressive research papers. But I mean, the systems evolve like babies. They will start like very young, and then they will like scale up as you go. So the more you work with a varied kind of system, the more you start to develop some kind of principles on how systems scale in production. And that's the thing like I think I'm lucky to have done. I've worked with production systems that have scaled from a few users all the way to millions of users at big companies and from startups. Some of these systems, they are very varied in the way they do. There are systems that are very heavy in the data processing. There are systems that are very compute intensive. And like having to, deal with all these kind of scalable systems, you develop like intuitions and learnings. And if you just, complement them with like research findings, a lot of like papers that have been written on this, you just end up building like a very strong foundation in like how systems scale up throughout their lifetime.
And what would you say, could you share some unique challenges that you faced in your career when developing or designing systems or growing them, transforming them from a lower scale to a higher scale? Just share some of your practical wisdom.
Yeah. Again, to start with, like, every system is unique. Again, like every system is unique. They are like principles that are written about them, but at the end of the day, they usually say nothing prepares you for impact with the enemy. So nothing prepares you for impact, a production impact. But there are, like, I think a couple of like generic learnings about like how to handle data, how to scale systems depending on the workloads they deal with. I would say like the first thing is like to try to solve the problem and then scale later rather than try to scale and then solve the problem. It could be, you could start with just like a monolith system, a system that's not very microservice based, and then as long as it solves the problems first, that's the most important thing. As the traffic grows, or like as the demand goes up, to like scale it up, you could start like breaking it up into like microservices and such, and then that's where you at the core of it, you have to make sure, like, in as much as you want to scale the system, you are solving the problems. Distributed systems come with like a lot of complexity. They come with a lot of operational complexity, a lot of maintenance complexity. So you don't want to incur that cost if you can solve the problem with a simpler design or like approach. So that's one of the key learnings. Like, okay, start small, start with a monolith, and then as the demand goes up, or like as the system requires you to scale up, it's when you start breaking it up into like a microservice architecture and such. The other thing is like to avoid being fixated on the tech stack. I think tech stacks are ephemeral at the end of the day. As long as they solve the problem, the tech stack can change, especially with like the current cloud native architectures. Like everything is containers, everything is is exposing APIs which are like language agnostic or framework agnostic. So the tech stack can evolve with like the modern architecture of like cloud-based applications. So there's no point of being fixated on the tech stack, really. I do think those are some of the learnings I've learned. And then production systems behave different than the lab system. So whatever you develop in your laptop, it will most likely behave differently in production. So yeah, you have to actually see how things work in production. You learn a lot by running them in production.
And to separate our conversation a little bit from the tech stack, what would you say the key qualities for a software engineer to work in this rapidly developing, rapidly changing market, and to work on progressively intensifying in complexity projects?
You have to be agile, kind of. Of course, I don't mean like just the agile method of development, but you just have to have an agile mentality, because the landscape, as you mentioned, is of course changing rapidly, and the way things are moving, like customers expect more from service providers. Even if you're providing a simple website that just says hello, they expect your service to operate at the same efficiency as Google. They don't expect your service to be down. And some of these services are very critical to people's income and daily livelihoods. It's very important to just like have a very high quality SLAs and quality of service when you're doing it. Be very agile in adapting to the tech trends, because they do change quickly, but at the same time, like, maintain a very high bar in the quality of service. And it's very easy to do that nowadays with like the cloud architectures. You don't have to have a manual scalable system. There is a lot of cloud applications, or like cloud infra on AWS or Google Cloud or Azure. As long as you are agile and you're adapting to trends, you can get the quality of, from like the current cloud providers.
Speaking about cloud platforms, I know you've worked on systems based around Google Cloud, AWS, Azure, all the three, sort of like the majestic three, so to speak, of the cloud computing nowadays. Could you tell us something about your experience with these platforms? Which of them you find more useful? Perhaps some of them lend themselves more to some sort of tasks and implementations. What is your overview of those three?
They're pretty much similar, except from the services offering and the APIs they expose. I mean, again, AWS is the most developed. It was the first in the market, so it does provide more services. Some of the services, there are no complementary services in the other providers, but at the end of the day, I think all of them are usually the same, and like there is like a trend now to move to like multi-cloud architectures, whereby companies or like enterprises are trying to not be reliant on one cloud provider. They will like use something like Google Anthos, to just like set up like, you know, a multi-cloud architecture. And then there is like this automation tools like Terraform, Ansible, which like also will automate regardless of the cloud. So I can't really say there is one over the other. It really depends on your preference. Again, there are enterprises that have been using a lot of Microsoft stack, so they prefer to move to Azure because they still stay in the same environment. And then there are others who prefer to stay on Google, and then there are others who are very experienced with AWS, or they have like some technical debt on AWS, so they just prefer to stay on AWS. But all of them do provide the same services, except from the APIs they expose, which could be different, but the underlying services are just the same.
So if those are quite similar at today's level of development, what would you say would be considerations if for a team that would be starting from a blank slate, just picking one of the three platforms, what would you advise to consider to keep in mind when making this decision?
I would say it's just like on the architecture of your application and the problem you're trying to solve. I mean, if I was to like develop a quick prototype on my laptop now, and I want to deploy it quickly on the cloud, Google provides something like Google App Engine, which will quickly deploy the application for you, and you don't have to maintain the infrastructure. Again, AWS provide a similar service, and Azure also provides the app service, which is practically similar. So with like the recent development in, especially as I mentioned, like on containerization and abstracting the infrastructure away from the application logic, you can really develop an application overnight if you're starting up and deploy it on any of these cloud platform. You can bootstrap a Google Cloud project quickly, you can bootstrap an AWS project quickly, you can even bootstrap an Azure project quickly and have it running in a few minutes. It's like with the modern cloud functions, it's very fast, and it's very agnostic of the cloud provider you choose. So I would say it's preference, up to you. Like if you like to code in Python or some Golang or something, any of these cloud providers allow you to like quickly prototype and like deploy your project.
And what about handling data privacy and security in the context of the backend? What would you, from your point of view, what would be the best practices or the things to avoid, or basically some tenets that you should keep for yourself while developing a data-intensive, scalable system?
Privacy is a very hot topic, and you know it deserves the attention, again, because it's people's data you are handling. And I've seen it like being applied differently in different companies. From all the companies I've worked with, there are companies, you know, that every company has their own way of like handling privacy. Some of them will use like something like as a privacy review, whereby you develop your application, and then before you roll it out, you have like a privacy team that will like review the application and make sure it's complying to the local laws to where it will be deployed. For a startup, of course, it can be hard. You probably don't have a privacy team. It's just a couple of engineers. There are also like a lot of tools nowadays that try to enforce like some privacy rules, especially like GDPR rules and like data residency and such. So one of the things I would advise is like to really abstract the data layer from the application layer. The data is the one that most of the time has like regulatory requirements of where it is, of where it can sit, where it can be processed, and where it can be transferred in. So if you, as a team, if you're able to just like safeguard and abstract the data layer away from the application logic, you can put a lot of safeguards on how the data is accessed. And of course, like you have the basic fundamental things like authentication, strong authorization, and a least privileged role-based access model. So prevent like manual modification of data. And whoever has access to data, they need to have the least privileges to carry out the function they need. And then try to routinely make sure like everyone who has access of the keys to this data, they are being refreshed or they are being revoked if they are not being used. So those are like I think like best practices when you want to handle a secure system, which could involve some sensitive data. If it's financial data, I think that I really think like there's international laws on like handling financial data. So for you to be compliant, I think you usually have to go through like a lot of regulatory framework and checklist. So if you just follow this and like the tooling that providers provide for this, then you most of the time will be like compliant.
You mentioned the differences between working in a corporate environment where we have whole teams dedicated to specific issues and versus working in startups in lean cultures with limited resources. Jumping off from that, how would you say the companies you've worked for over your lifetime have influenced you as a developer, as a software engineer, or helped you or nurtured you in some way? Just share some experiences of your sort of working career and your relationships with the companies you've been working with.
First, I think there is usually difference in speed of movement. Again, is because like as everyone knows, younger companies, you probably don't have a huge user base and you're trying to grow your market yet. So most of the time, the focus is on speed and releasing features to users, because that's the target, to maybe increase the user growth or like revenue and such. You can have like your company specific metrics you want to focus on. And because the team is very small, I think you tend to have to do everything that needs to be done. As I mentioned, like most of the time there is no privacy team. It's you as engineers, and then you have like a couple of people who support you as engineers, and then you have to just do as much work as possible. I think in the previous startups I worked in, I had to do operation work, I had to do development work, and then have to do like testing work, all of this. But again, when you are in a bigger company, in a corporate, you have like a testing team, or like your test engineers, and then you have like the operational or like SREs, which handle the reliability and the production environment, and then you have the feature development teams, which actually implement the features. I mean, working in all these different environments, it requires like different principles. In a smaller company, you have to be agile and you have to very focus on velocity, and then in a bigger company, you have like a lot of like team collaboration. So you try to focus more on collaboration, you try to focus more on compliance, and you try to focus more on like following the corporate way of doing things.
So finally, any advice for people who might be just starting their software engineering journey or wishing to focus more on the backend side of things? Could you maybe share some wisdom and to help them build their career like you have?
It could be in different stages in your career. Maybe you're in school yet, you haven't like really chosen one path to go to. For those, I think I would say like try to be open-minded at first. Don't dive into, don't fully commit. I would say I would consider myself to be a generalist. I can be able to move between different languages and stacks. So, and I do think it's very important to have that generalist mindset, because you get to see the whole picture. So if you're starting out, I would say try out different parts. Do some backend, do some operations, maybe try front end if you have time, maybe do mobile if you feel so, and then you can have like the full end-to-end picture before you try to choose like one part of the stack. And if you are like you've already started and you're like a mid-level engineer, then I would say there is a limit to how much you can learn on books. and like you need to actually, try to build things in production, try to run things in production. There is a lot of invaluable knowledge you learn by, just running a service in production. That would be like, those learnings are the ones that, differentiate or move you to the next level in like, being experienced by actually running services in production.
That's a good one. And just to round this off, a loaded question for you. Your favorite language at the moment? One that you're finding yourself using the most or enjoying the most?
Yeah, this one is a cliche, I guess. Everyone loves Rust, so I've been writing Rust the past 2 years, and it's amazing. So yeah, I would go with Rust.
Okay, good. Well, Miles, thanks for joining us. Thanks for your insight and expertise. It's been a pleasure talking to you.
Yeah, you too. Thank you so much.